All right, we're getting to the home stretch in terms of information we need to make a graph. We've done end behavior, we talked about x-intercepts and when they are cross points or touch points based on their multiplicity. We need to build up just a couple more odds and ends. Some of this stuff is kind of review to a certain extent, but we're just going to sort of make sure we've talked at least through kind of one example of everything before we try to put it all together. Next on the list is finding y-intercepts, and we're going to talk a little bit about symmetry of the functions and what that would mean. Let's do y-intercepts first because they are extremely fast and easy to find. So y-intercept, right, is where you're crossing the y-axis. So if we draw our generic curve, going up, doing some things, x-intercepts, right, here, here, and here. The y-intercept is only ever going to be one of them. I don't know why I should just say y-intercept and not y-intercepts. There's only ever one, our y-intercept, right, because to be a function, you have to have unique values for all your x's. So the y-intercept happens where the x value equals 0. So x-intercepts happen when the y is 0 and you have to solve for the x. The y-intercept happens when the x value is 0 and then you can solve for the y. So the good news here is that this is extremely easy to find. All we need to do is evaluate f of 0, and that's going to equal our y-intercept. If we let's just do sort of two kind of quick generic ones. We'll do one that's sort of unfactored and one that's like prefactored. How about right, x squared minus 5x plus 6. This is kind of similar to one that we did before. So that's our f of x. So if we're going to find the one and only one, y-intercept, all we're going to do is sub in f of 0. So just subbing in x equals 0 and then just evaluating it. F of x, f of 0, right, is one of our best and easiest substitutions because, of course, anything multiplied by 0, 0 squared, 0 to any power, is just going to give us more zeros. So a lot of these terms are going to fall away. 0 squared, right, is of course 0, minus 5 times 0 is of course 0. And so pretty quickly you can see we're just left with this plus 6, this sort of constant on the end. And that's going to be our y-intercept. That will happen a lot of the time if we have an expanded polynomial, right? If you have a constant term, all the x terms will just wipe out, right? Because they're going to be subbing in x equals 0. They're all just going to clear away. You're just going to end up with that constant on the end. If you have a different example that's maybe like prefactored, we'll maybe do two of these prefactored ones first. So maybe we've got like a 2x squared times an x minus 3 quantity squared times an x plus 2 or something. So if we find the y-intercept, sub in x equals 0, so g of 0. So because this is just showing up in a slightly different form, it makes the sort of math go a little bit differently. So 2 times 0 squared, we'll just sub our zeros in to this whole thing, and then we'll just deal with it. And to a certain extent, this is going to go very quickly because, well, 0 squared is 0, 2 times 0 is 0. This is 0 times some other stuff. This would be negative 3, right, quantity squared. This would be positive 2. But like, if they're times 0, then these numbers don't even matter. If everything here is times 0, we're just going to get 0 as our y-intercept. That would mean it's going through the origin, right? This would get us the sort of x is 0, y is 0 point. This is sort of up at 0, 6, our previous one. The the temptation might be to then say, okay, if I get any of these prefactored ones, I'm just going to get 0 as my y-intercept. If you have an x out in front, then yeah, you will. If you get a prefactored one that doesn't necessarily have an x in front, right? Maybe it's just -3 times x plus 2 quantity squared times x minus 4 quantity squared or something, right? Maybe that's what you're working with. So it's prefactored. It's got a number in front, but it doesn't have an x on it. So if we sub in x equals 0, what's going to happen? -3. So the 0 is going in for the x. This is me partially realizing we're going to get kind of a big number here, but that's okay. So this is going to be -3. So 0 plus 2, well, that leaves you with a 2, right? 2 squared, 0 and -4 leaves you with a -4, and then that's squared. So this is going to get us -3 times, well, 2 times 2 is 4. -4 squared, negative times negative would be positive 16. Good grief. What the heck is this number going to be? 16 times 4 is 64. -3 times 64. 3 times 60 would be 180. 3 and 4 is 12. 180 and 12 would be, so -192. So that's a pretty big number, but that's going to be our y-intercept. So we get this sort of 0 and -192. So that's a pretty extreme number relative to some of the other examples we've done. But in theory, right, that's the kind of thing that like could happen. So just subbing the 0 in here and finding our value. Why don't I pause there actually, and we'll do our symmetry in a second video.